All right, so there we go. They want us to plot a point on a graph. So we'll start from the basics. Plot 0, 4. They want me to put 0, 4 on the graph. How do I put 0, 4 on the graph? Where's it going to go? Remember, yeah, do you know any of this? We're assuming you don't know any. So the first number is over, the second number is up or down. First number is x, the second number is y. This is the x-axis. See the x here? The sideways one. And the vertical one, the up-down one, is the y. So we have the y-axis, the x is sideways, the y is up-down. So the first is x, it's over. The second number, the 4, is the y, it's up or down. So starting from the middle, you always start from the middle. Let's do what it's saying. What is it saying? Starting from the middle, go over 0. Okay, I went over 0, and then up 4. So I end up right there. That's over 0, up 4. Two numbers make one dot, one location on the graph, don't they? Over 0, up 4. Is that good? Does that make sense? Over 0, up 4. Questions on that? That's all they want. So let me show you how the Math Excel little graph maker works. Where's quadrant 1? Yeah, upper right. This is quadrant 1, 2, 3, 4, huh? Right? 1, 2, 3. We use Roman numerals so that we don't confuse them with the other numbers that are on the graph. So 1, 2, 3, 4. So this dot here that they're giving me is in quadrant 4. Quadrant 4. Good? They put a dot right here. It's in quadrant 4. Keep moving. It's going to make me try to figure it out without that. Okay? So I'll draw my own little axis system here. They want me to find the point negative 7.4 comma 0. Can you do that? So remember the first number, let me write it here. The first number is over, the second is up or down. First number is over, the second is up or down. So how do you go over negative 7.4? That's sideways, huh? So that's back 1, 2, 3, 4, 5, 6, 7, and a little bit more. Up 0. So there it is. It's right on that grid line, huh? Does that make sense? I went back 7 and a little bit more. It doesn't matter. We're not being super exact here. It's just back 7 and a little bit more, 7.4, and then up 0. So it stayed on the grid line, didn't it? It's right there on the grid line. So this is the x-axis and the y-axis, so it's on the x-axis, huh? It's not inside any of the quadrants, it's on the x-axis, isn't it? Make sense? Notice something with me. When you're on the x-axis, like this point is, it's on the x grid here. This is x and y. Its y coordinate is 0. Opposite letter is 0, huh? That's always the case. When you're on the x grid, your y is 0. When you're on the y grid, your x is 0. We'll use that to our advantage in a little bit. Everybody notice that? Right? This dot is up 0, so its y coordinate is 0, which means it's on the x grid, isn't it? The opposite letter is 0 when you're on a grid. If you're on the x grid, the y is 0. If you're on the y grid, the x is 0. That's what that means. All right, let's do that one. Okay, so 3 and 2/3 comma minus 1 and 6/7. So we're supposed to put that on the axis system. I wouldn't even worry about the mixed number. Just do 3 minus 1. Who cares about the 2/3 and the minus? It's not exact. You're just trying to find out what general quadrant it's in. So go ahead and just do that. Just do 3 negative 1, you know. Find out what quadrant that's in. So starting from the middle. Remember, the first number is over. The second number is up or down. So I'm going to go over 1, 2, 3. Positive 3. So go to the right 3. And then negative 1. down 1. So right there. Over 3, down 1. And 3 2/3, 1 6/7, about the same place, you know. So which quadrant's that? This is 1, goes counterclockwise 2, 3, and this is 4, huh? Quadrant 4 on that. That good? So the two numbers with the parenthesis and the comma, first one is over, second one's up or down. You can't reverse that, it'll mess you all up. First one's over, second one's up or down. X then Y. All right. All right. So in which quadrants is the first coordinate positive? You know, you have the two numbers. This is the first one, the second one. So if this first one is positive, let's just do one, like positive 3 or something, comma, whatever. If the first number is positive, that's what they're saying. If the first coordinate, the first of the two numbers in the parentheses, with the comma in the middle, if the first one's positive, positive 3, and then the second one is who knows, positive or negative, whatever. What possible quadrants could you end up in? Where could that dot, it could be more than one place, where could that dot end up if the first coordinate is positive 3? Yeah, because if you start in the middle, we start in the middle, go 1, 2, 3 to the right, positive 3. And then the other one could go up or down. We don't know. Could be positive 7 or negative 6 or whatever. Who knows? So it could end up in quadrant 1 or 4. So I want you to go 1, comma 4. The two answers with a comma in between. Does that make sense? Just making sure you understand this quadrant thing and the coordinates.
Wait, the answer would be what? 1, quadrant 4?
Yep, because they say use a comma, and here's the different quadrants. It could end up in this quadrant 1 or in quadrant 4. Because the first number is positive, so we go right 3. The second one, we don't know. So it could be up or it could be down.
So how would you type in the answer?
Yeah, just literally like that. Just literally like this right here. You just do a 1 and a 1V with a comma in between, yeah. All right, why don't we stop there? We'll take our 10-minute break. Right there. All right, are we ready for more? Can you, we're gonna go backwards now. And they want us to, they're giving us the dot, and they want us to write the coordinates. You know, like the two numbers with the parenthesis and the comma. So for that dot right there, can you find the coordinates of that dot? So remember, the first number is over, and the second number is up or down. So over, comma, up or down, give that a try. So starting from the middle, starting from the origin, how far over do you have to go? Yeah, back 1, 2, 3, looks like. And then up 1, 2, 3, 4, huh? That good? Back 3, up 4. All right, so they want us to determine whether negative 3, negative 9 is a solution of that equation or not. 8x minus 5y is 17. This is x. This is y. Okay. So, they want us to take this and plug it in for x, and take this and plug it in for y. Like that. And they just want us to determine if it works out to be true or, equal or not. If it's equal, it's a yes. So let's just plug it in. So 8 times minus 3 minus 5 times minus 9. Does that equal 17? With me so far? So you just plug in the x and plug in the y. You got to remember that it goes alphabetical, right? So the first coordinate is x, second is y, alphabetical. Plug them in. Minus 24. It's going to be plus 45, right? because of the double negative there, huh? Two negatives. A plus, and then what is that, 21? No, 21 doesn't equal 17, no. So that's what it means to be a solution to an equation. When you plug in, it makes it true. So if it doesn't make it true, it's a no. We good to there? All right, so that one's, if they'd come out equal, it'd be yes. So it's a no. All right. So jumping forward to problem number 10 here. They want me to graph, so we're going to start graphing now. How do you actually get a picture of an equation? Well, it's going to be a straight line, and to get the line we need two dots. It's basically the game plan. So we're going to find two dots, like maybe here and here or whatever. Those are supposed to be dots. And then we'll connect the two dots to get a straight line, and that'll be our graph. So that's the idea. So how do we find those two particular dots? Let me rewrite the equation down here and we'll talk about that. Okay. So anybody know already, like this method? Like, where do you get your first dot?
The 4.
The 4, yeah. This one right here, you start up 4 in the middle. If that was a minus or subtract 4, then I would start down 4. So I go up 4 in the middle, boom, right there. There's my first dot. Up 4 on the middle line. Everybody see that? That number off to the right is your starting number, and it's always right on the middle line. If it's positive, it's up in the middle. If it's negative, it's down in the middle. And that's your first dot. Put that first dot there. Now, how do we find the second dot? Because we just need one more, right? We're halfway there. One more dot, two dots, connect them, got a line, we're done. So how do we find the second dot? Yeah, it's this fraction right here is a rise over its slope, actually, which we'll talk a lot about tomorrow, is slope. For now, we'll just start to get the flavor of it. It's rise over run. Have you seen that before? Rise over run, slope. So that tells you, just like a road map or signpost, how to get from the first dot to the second dot. So we already have the first dot, right? So now I'm not going to go back to the origin. Now I'm at this first dot. From that first dot, how do we get to the second? Well, we go up 1 and we go over 2. Go up 1, and over 2. 1, 2. Right there. Is that good? Everybody see what I did there? I went up 1 and over 2. And that's your second dot, and it's done. Just connect those two dots, you got your line, you're done. And that's the second dot there. So now I'll just connect the dots. And we're done. Is that good? Questions on that? Is that okay? So again, whatever number's off to the right, that's your starting dot. Positive, it's up. Negative, it's down. Always in the middle. So plus 4, it's up 4 in the middle. There's your first dot, and up 4 in the middle. And then to get from your first dot to your second dot, it's like a signpost that the fraction in front of x is technically called a slope. It means rise over run, meaning you go up 1 over 2, and that's your second dot. And then you just connect the two dots, and you got your line. Let me show you how it works on the actual math. Is the Y-intercept. Okay, now what's that? What do they mean by the Y-intercept? Do you know? It's where the graph intersects the Y-axis, the Y-grid. Which one's the Y-grid? This is the X, this is the Y. Right? The Y-grid, so it's, in other words, it's that point right there. That is the Y-intercept. It's that point right there. That's the Y-intercept. What's the coordinates of that point? Now, when I say coordinates, remember it's two numbers. Every one dot on a graph, one dot has two numbers to locate it, right? The first number is your over, your X value. Your second number is your up, down, which is your Y value, huh? So that one dot has two numbers to locate it. What are those two numbers to locate that one dot? This one's over 0, up 4, isn't it? Because this was back when we were doing the 4 one. It switched when I changed it, you know. So that one's over 0, up 4, you can tell, huh? And that's it. That's the second answer they want. They just want the coordinates where the graph hits the y-axis. Is that good? We okay with that? It's called the Y-intercept. Okay, try that one. Y equals negative. Oh, I haven't shown you negative yet, huh? I haven't shown you negative. So y equals, well, let me do this. Just put that negative on the top. Just throw that negative up on the top. Throw it in the numerator. Remember, a negative on a fraction, it doesn't matter where it's at, as long as there's only one of them, right? You can have the negative in the front. You can have the negative on the top only. You can have it on the bottom only. But you cannot have it on both, huh? Why not? Why can't you have it on both? Why doesn't the front go to both? Because two negatives would be positive. That's different. That can't be. Right? So you put it on the top only or the bottom only. So I usually just throw it on the top. It's just easier that way. So take it from there. So, but anyway, that's not where you start. You start with the stuff out here, don't you? You start out here. Start up 3 in the middle, because that's a positive 3 out there. So start, your first dot is going to be up 3 in the middle. So start up 3 in the middle. Is that good right there? Up 3 in the middle. Now, where do we go from there? Oh, by the way, this graph's going by 2s. Did you notice that? Right, it's going by 2s. So to do up 3, I had to go, between the 2 and the 4. So that's up 3 right there. It's kind of hard to see it all. All right, that's the first dot. Plus 3, up 3 in the middle. Now, how do you go from that first dot? Right, we're not going back to the origin. It's from that first dot to the second dot. Yeah, it's rise over run. Remember that fraction in front of the x is like a signpost. So how do you rise negative 2? Down 2 over 3. That's why I like to put the negative on the top, because that way it just means down, but I'm always going to the right this way. The bottom is still positive. It's still to the right. Down to right 3. I think that's just easier. So down, how do you go down 2? Well, remember, all these are going by 2s, so down 1, down 2 is like half. I can't even do that. There's not even room for me there. I'm just going to go like right here and say, okay, the first dot's at up 1, 2, 3. Right, that's our first dot. And then from there, I go down 1, 2, over 1, 2, 3. There's my second dot. Down 2, over 3. Down 2, over 3. Everybody see that? Get our second dot. And then automatically, Math Excel will connect the dots for you. On the exam, you'll just connect them yourself, and you'll look at the multiple choice answers, and you grab the picture that looks the same as yours. Is that good? Does that make sense? And they will also ask, what is the Y-intercept? Can you give me, remember, that's two numbers with a comma in the middle. Can you give me the coordinates of the Y-intercept? Yeah, first number is over, second number is up or down, huh? So this dot right here is what we're talking about. The Y-intercept's right there. Right, where it hits the Y-axis, the vertical grid. So that's what? Over 0, up 3, isn't it? From the origin. From the origin you go over 0, up 3. Don't you? Is that good? Questions on that one? All right, I'm going to move along. More and more comfortable with all this. All right, try this one. So y equals 3/2 x plus 4. So try that one. So you get your first dot, and then do the rise and run to your second dot. All right, we start up 4 in the middle. There we go, up 4 in the middle. And then where do we go from there? Up 3, and you run. Your rise is up, down, run is sideways. So, in fact, that's too small for me there. I'm going to just do it right here. So up 4, 1, 2, 3, 4. And then go up 3. 1, 2, 3 over 1, 2. Up 3 over 2. Connect the two dots. There we go. All is well. Easy graphing. It's number 12. Okay, so there's number 9. Y equals x minus 2. Try that one. Hey, there's no fraction in front of x. So what should we put in front of x? Yeah, and you got to make it a fraction, so make it 1 over 1, huh? Because that's the same thing as 1, and 1 times x is still just x. We haven't really changed anything. So do that. So take it from there. So if that fraction in front of x is missing, it's 1 over 1. Where do we start? Start down 2 in the middle, huh? Is that good? Down 2 in the middle? And then where do we go from there? Yeah, up 1 over 1, boom. There's our two dots. Connect the dots, got our line. Is that okay? Start it down 2, go up 1 over 1. So if that fraction in front of x is missing, it's 1 over 1. All right. Not only the fraction in front of x, but the back. So we just have y equals x. So we know the fraction, we're supposed to graph y equals x. We know the fraction in the front, when it's missing, is just 1 over 1, because that doesn't change anything, right? Notice how we always put stuff in that doesn't change anything. 1 over 1 is just 1. 1 times x is just x, right? Okay, but now we also need a number like added at the back. What number can you add at the back that won't change anything? Can I add 1?
0.
Yeah, you got to add 0. Everybody see that? If that number, it's 0 if missing. Why? Why is that one not 1? Because adding 1. So if it would, yeah, let's put it this way. Adding 1 would change things, wouldn't it? Everybody see that? So when added number missing, it's 0. When multiplied, missing, it's 1 over 1, right? Because multiplying by 1 changes nothing, and adding 0 changes nothing. Huh. You can't add 1. If I take 7 and I add 1, it's changed. It's 8 now. You with me? But if I just add 0, it's still 7. Didn't change anything. If I take 7 and I multiply by 1, I haven't changed anything. It's still 7. So you see how you can multiply by 1 or add, and 1 is the same as 1 over 1, huh? Or add 0, and nothing changes. So that's what we do. We just make this, see, this looks different, but it's real. That's still just y equals x, isn't it? 1 over 1 times x, that's just x. Add 0, that's still just x. That's just a fancy way to say x. And why are we doing that fancy way to say x? Because that's helpful for our graphing. We need to have a number back here to start with. And we need to have numbers here to rise and run with to know how to do our graph, huh? So we just put in numbers that don't really change anything. So that's still just x over there, isn't it? But now we know how to graph it. So we start at 0, right smack, I must do it right here, right smack in the middle, start at 0, and then go up 1 over 1. That's so much of math. I mean, it's just putting in stuff that's missing and, you know, making it look different to help us do what we need to do. All right, so there we go. Connect the dots. We got a graph. Oops, I kind of missed. It's the diagonal line right through the middle, isn't it? Good on that? Questions on that one? All right, let's take a look at those. So there's 13. 6y plus 5x is minus 18. All right, what's the deal with, we're still graphing, but this one's got something different going on. What's different about this one compared to all the other ones we've graphed today? Shall we look back? If you're not sure. So look at this equation. Let's look back. Look at this equation. Yeah, look at this equation. See how y is alone, y equals? Look at this equation. Y is alone, y equals. Look at this equation. Y is alone, y equals. Look at this equation. Y is alone, y equals. See how they've all been y alone, y equal, but not this one. Y is not alone. We don't have y equal. We got to make it happen. Yeah, so this one is the first one where we don't already have y alone. So first, get y alone. Solve for y. Yeah, here's the wall, y, which is kind of weird. We're used to doing this with x, but now it's y. For the graphing, it's y, not x. Y is saying, I want to be alone, get me alone. And as soon as we do, then we can do our normal graphing thing. So go ahead and solve that equation for y. Get y all by itself on that one. What's the first step to get y alone? Y is over here. Said, I want to be alone. Get rid of the stuff that's with me so I can be alone. Subtract the 5x. Good job. Now, can I bring down the 6y here? Can I go minus 18 minus 5? What's that? Minus 23x? No, that's wrong. Well, I can't combine those. Why not? This guy, if this guy had an x, that'd be great. But he doesn't. Right? If that 18 had an x, then yeah, they'd be like terms, wouldn't they? And they could combine. But if the 18 does not have an x and the 5 does, they're no getting together. They're not like terms. So what then? They just stay separate. And usually we put the x in the front. You don't have to. It's just tradition. It's not wrong. You can switch the order. It's not wrong. But this is how you're going to be seeing it all the time. So probably easier for you just to do that traditional thing. So does that make sense then? They can't get together. They got to stay separate because they're not like terms. One has an x, one does not. Last step to solve for y? Divide by 6. So there it is, minus 5, 6x minus, and then 18 divided by 6? It's just 3. Now, can we graph it from here? No. Yes. We can. So let's graph it. Where do we start? Yeah. Start down 3. It's always in the middle, huh? 1, 2, 3. Down 3. There's our first dot. At down 3. And then how do you get from that first dot to your second dot? Yeah, rise over run, huh? Rise over run. So I'm going to go down 5 more, huh? 1, 2, 3, 4, 5. Down 1, 2, 3, 4, 5. 3, 4, 5, 6. So down 5 over 1, 2, 3, 4, 5, 6. Down 5 over 6. Connect the dots. Is that good? Everybody see that? So we start at down 3. Then we go down 5 over 6. Down 5 over 6. 2 dots. Connect them. There we go. Is that good? So we had to first do the work to get y alone. And then start it down 3, and then go down 5 over 6. Questions on that one? You never have many questions. If you need to go out, just throw that door open as fast as you can right there. I'm just kidding. There's a guy in a ladder outside the door. I'm joking. Sorry. There's going to be a formula relating to bottled water drinking over time. People are drinking more and more bottled water, right? Since this is one of these word problems where they start off at a certain point in time again, 1971. So that all the information is since 1971. T is the number of years since 1971. So, since 1971, more and more people have been drinking bottled water. So, this is a formula right here that they're giving me. Oops, scribble. So, let me write it. N equals 0.733 T plus 8.398. So there's a formula they're giving me, which is connected in number of bottled water, number of gallons of bottled water by a person per year, and T is time in years after 1971. All right, what do they want me to do? Predict the number of gallons consumed by a person in 1978. 1978. What? How do I do that? Any ideas? What do they want me to do? How can I use this formula to find 1978 bottled water consumption?
1971 minus 1971.
Right. Yeah. So first off, what is the T value? Right? 1971 is the start. Right? T is years since. T is however many years after 71, right? So if it's 1978, how many years after? 7 years after 1971. Everybody good with that? Right, if it's 1978, that is 7 years after 71. So they want me to take T equals 7 and plug it into the formula. Hit the buttons on your calculator. Is that making sense? So it's going to be N equals 0.733 times what? 7 plus 8.398. And that'll come out, I have no idea. Is it like 13? Well, I do have an 8. It's going to round to 14. It'll round to 14 because I got the answer already from the computer. It's going to round to 14. Would you guys get 13.99 or 14.01? 13.5? So it rounds to 14. The nearest whole. They asked you to round nearest whole number, so 14. All right, let me slow down there for a minute. So everybody see what I did there? You getting the hang of this time thing? They do this all the time in science formulas. This is very, very common. They'll pick a starting time, 1970. We've already seen 2 of them today, right? 1971, And then any other reference to time is however many years after the starting time. So when they say 1978, I go, oh, subtract those, what's that, 7. So they're saying, hey, we want to know about 1978. So what they're really saying is, hey, take t equals 7, because that's how many years 1978 is after 71, and plug it into the formula and work it out. So it rounds to 14. That's how I got this answer right here. That means what? In 1978, the average person drank about 14 gallons of bottled water a year. It's going up with the years. Now, they're saying, hey, how about 1992? I bet it's more. 1992, how much bottled water did the average person drink in 1992? Can you figure that out real quick? Let me let you do that rather than me just whip it out too quick. 1992. So what are you going to plug in? I'm running out of room here. 92? Subtract 1971, 29, what was, I don't know what that is. 21? 21 years. So it's 21 years, so t equals, so you're going to plug t equals 21 in. Does that make sense? T equals 21, plug it, where? Same formula. 0.733, plug in 21. Right there, 21. And I guess it rounds to be 24. Is that right? You guys getting that? So there we go. So that means 24, it's gone up, right? 1978, average person drank 14 gallons of bottled water. 1992, they're drinking a lot more, 24 gallons of bottled water per year on average. It's gone up quite a bit, almost doubled. Is that good? You guys tracking with how to do this word problem thing? Now, last question is, hey, put those two dots on the graph and give me a graph of this thing. How do I do that? Well, what you want to notice is that the information, first off, notice it's not an X, Y graph. What is it? It's a T, N graph. So T is playing the role of X, and N is playing the role of Y. So it's a T-N graph instead of X-Y. So that's how they do real life stuff, right? They don't choose X and Y. They use age and income, or time and number of gallons of bottled water, real life stuff. So what does that mean then? Well, that means when time was 1978, which was 7, when time was 7, N was 14. That was the first calculation we did, right? That tells me the point 7, 14 on the graph, right? When t was 7 and I plugged it in, I got N 14, didn't I? That's like XY, except it's TN. You tracking with me? So that means go over to the point over 7, up 14. See if I can find it. This is 7 here, up 14. There, I think it's it, right? Hard for my eyeballs to see that. Yeah, looks right. 7, 14. Over 7, up 14. Everybody see that point? Everybody good? That's over 7, up 14. That's the first dot. At 7 years after 1971, in the year 1978, person drank on average 14 gallons of bottled water. Now, the next one, the next point we found is 1992, which was 21 years after the start, in 24. So that's the point 21, 24, isn't it? 21 years after this thing started, that's T, and then N, they drank 24 gallons. So go over to 21 here, 21, go up to 24. Right there. I think I got that. Yeah, 21, 24. There's the dot. 21, 24. And now, right, everybody tracking with me? Y'all with me? This making sense? So these two data values produce two dots on the graph. Instead of xy, it's tn. Right? And now you just connect the two dots with a straight line. MathExcel will do that part for you automatically. And you get a graph of how bottled water consumption has grown over time. There it is. That's how they do these kind of things. They take real life data. Instead of an XY, they make it, real life things like time and number of gallons of bottled water, and they put dots down, and they connect the dots, and they get real life graphs. That's how you see these graphs. They say, oh, here's bottled water, the growth of bottled water consumption over time since 1971 is this linear graph, da-da-da-da-da. That's what they do. Does that make sense on that? That's the kind of thing you'd want to see if you were investing in bottled water. It's going up, up, up. The future looks bright. All right. I'll leave that one be.